development of the atom through time is really one of those great stories of scientific progress, showing how a new experiment can really change the way that we understand the entire world, because science is always based on experiment and evidence that we collect. And as soon as that evidence disagrees with our current theory and our current way of thinking, it means we actually have to change the way that we understand one aspect of the world. So when Ernest Rutherford discovered the nucleus in the center of atoms and that atoms were almost entirely empty space, it meant that they had to rework the plum pudding model of the atom into something different. Now, Ernest Rutherford's idea of using the nucleus with electrons around the outside did have its own problems, and a lot of it came from the fact that there were new experiments taking place. You see, one of the experiments that people were doing is trying to find out how different substances and different elements ended up giving off different colors. So a great example of this is if you were to go outside at night and you see the street lamps, if you see the street lamps in any city, chances are the really old ones are orange in color. And this is because there's sodium on the inside. Some of the still slightly older ones that are not LEDs but are still quite bright might be like a bluish color. And that's because they are filled with mercury. And something people were discovering is that when you put electricity into an element, that element gave off its own unique set of colors. And what that means is there is something going on inside the atom that is related to the fact that different elements give off colors. So this is something Rutherford's model could not explain. And when we have something we can't explain, we need a new model. This is when we come to Niels Bohr. Niels Bohr was a Danish physicist and one of the founders of quantum mechanics. So we're going to take a look at his model of the atom, and I should mention up front, the Bohr model of the atom is not the most current model of the atom. It is very good. It explains a lot, and it's great for the first 18 elements on the periodic table. Above that, it's not so great. And there's a lot of aspects about the way that the atom works that cannot be explained about the Bohr model. But the Bohr model explains a lot. And for a high school level, it's a pretty good model for us to be able to use. So let's take a look at what it is. The Bohr model starts with a nucleus. So inside the nucleus are the protons and neutrons, and that's no different because Rutherford discovered this, and we know that that is true. The next thing is he said there are electrons, and those electrons exist in different, what he called orbitals. And the reason they're called orbitals is because they're kind of like the orbit of planets around the sun. He also said that these orbitals can only contain a certain number of electrons depending on which orbital they are. So the first orbital, the first ring, he said could only hold a maximum of 2 electrons. He said the second orbital could only hold a maximum of 8 electrons. And the third orbital could hold a maximum of 8 electrons as well, meaning the first 3 orbitals or rings around the nucleus of an atom can hold a maximum of 18 electrons. So you may be frustrated right now, like wondering, why doesn't it go like 2, 4, 6 or like 2, 8, 16? Because it doesn't. That's the evidence told us that it doesn't work that way. The evidence came from actually looking at the ways that things connect together and the ways that elements combine to form compounds. Whether we like it or not, this is the way that it goes. We can't change our model to be what we want it to be. It has to be based on the evidence that we collect. So whether you like that it's 288 doesn't really matter because it is what it is. So let's say we were drawing an element of, or an atom of, let's say, sodium. So sodium is Na. If we wanted to draw our atom of sodium, we would want to know protons, neutrons, and electrons. The protons are based on the atomic number, which is 11. The neutrons are the atomic mass minus the protons. That tells us the neutrons. The electrons, those in a pure element are going to be the same as the protons. So we need 11 electrons. We would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now that this ring is full, I still have 1 electron left. I go out to the next ring. A few rules here. You have to fill up an inside ring before you can move to an outside ring. So the first orbital has to be full before electrons go in the second orbital. Second orbital has to be full before you put electrons in the third orbital. If you wanted to continue, you'd have to fill the third before the fourth before the fifth, and so on. This is the Bohr model, the idea that you have the nucleus at the center and electrons in orbitals around the outside. One of the things that I mentioned is that in order to explain the atom, they were really looking at the colors that were given off by atoms. So how does the Bohr model actually explain this? Well, it all has to do with those rings. You see, those rings around the nucleus are considered to be a specific distance away, and that distance is going to be different for every element, but it also corresponds to the amount of energy that is required for that electron. So for the electron to be at this orbital, it has to have this specific energy. For it to be at the next orbital, it has to have a slightly different energy. For it to be at the next orbital, it has to be an even different energy. In fact, the energy increases as you get further away from the nucleus. Now, what is actually happening here is the electrons want to be at the lowest energy they can possibly be, but they can't jump down to a lower orbital if it's already full. But what can happen is you can put energy into an atom. And when you put energy into an atom, if it's the right amount, you can actually cause an electron in that atom to jump to a higher energy level. Now, electrons are lazy. They don't want to stay at a higher energy level. So what they're going to do is actually jump back down so that they can get back to their original energy. When they do this, they have to account for the amount of energy that they lost. And that amount of energy that they lost is going to be given off. And it's given off in the form of light. Different energies of light are actually different colors. So red light has a little bit less energy than blue light. Ultraviolet light has a little bit more energy than blue light. And so you can have different amounts of energy based on the different colors in the light. The colors in the light are based on the differences or the colors given off by atoms are based on the differences in those orbitals. And this is what Niels Bohr used to explain the observations that they made. Now, a few quick notes about electrons in this model. Electrons must exist on a line. They cannot be in between. They cannot be slightly past. And I know this seems weird, but they just don't exist here. They exist here, here, and here, nowhere else. You see, electrons always have a certain amount of energy, and that's called quantized energy, a specific quantity. So they have to have this amount or this amount. I always say, imagine moving around your house, and you could exist in your bedroom, you could exist in your kitchen, but you cannot exist in the hallway. That's kind of what life is like for an electron. They can go from their bedroom to their kitchen if they get enough energy, and then they'll jump back to their bedroom as soon as they give off that energy. But there's no walking from one place to another. There is just the appearance from one to the next place. And that's how electrons work. They jump from one orbital, straight to the next, and back with no in between. I know it's weird, but that's kind of how atoms are. And it's also eventually going to be important to understand that electrons do like to pair up when they have the chance. And I also find when you draw your Bohr model, it helps you keep track of how many electrons you actually have. Well, some of the biggest mistakes when drawing a Bohr model is miscounting your electrons. Okay, so this is the idea that actually changed the way that we look at the atom. The Bohr model led to a much more current model called the quantum mechanical model. And the Bohr model explained a lot about the ways that atoms work and behave and led to a new understanding of the chemical world. So hopefully this helps you understand the atomic structure. And up next, I'll be showing you a few examples so that you can do more Bohr models on your own.